Welcome to the second case study of the Activity Reconstruction module. This case study focuses on a suite of pathological lesions, in particular osteoarthritis and intervertebral disc disease, that can provide clues about the types and levels of physical activities in which past peoples engaged. So it comes as no surprise that we can damage and degrade the parts of our body, especially the joints, that we put a lot of stress and strain upon. Many of you may already have a bum joint, maybe an ankle or a knee, that you can attribute to a type of activity or an injury from the past. If you'd like, you can tell us about this on the online forum. Maybe you were a baseball pitcher and your shoulder never completely recovered. Maybe you're a runner and you can tell it's hard on your knees despite the other health benefits. Maybe you do a lot of fine handiwork like weaving or quilting or needlepoint, and your hands get sore quite quickly. What you're experiencing is likely some degree of joint degeneration. Probably for most of you it's manageable, and if you cease putting stress and strain on that joint, the degeneration and discomfort will largely cease. But for others, perhaps the damage is already too far gone and medical intervention is required, maybe even surgery. Knee and hip replacement surgeries are very common today, largely because of the unavoidable wear and tear that we put on these joints over time. And the same idea applies to people in the past. Joint degeneration leaves clear marks on the skeleton, so osteoarchaeologists can use these lesions to get a sense of what types of physical activities must have been commonly performed by an individual and a population. So let's discuss the two main diseases and pathological lesions that fall within the category of joint degeneration that we're talking about. First, the most widely studied disease in this regard, osteoarthritis. Osteoarthritis is a joint disease occurring only in synovial joints, wherein there's erosion of the joint cartilage. This can be quite easily recognized in bones according to 4 possible changes. First, new bone can form both on the joint surface as well as on the edges of the joint, called osteophytes. Also, the surface of the bone can become porous and pitted. The normal outline or contour of the joint can change or become deformed. And fourth, finally, areas on the joint where there's bone-to-bone contact can attain a polished appearance called eburnation. Now, as with a lot of the lesions and diseases that we've discussed in this course, osteoarthritis has a multifactorial etiology. Activity is but one of the factors that can cause osteoarthritis, and other factors, especially age, but also sex, genetic factors, body mass, the anatomy of the joint itself, and trauma all play a role. What we typically see in osteoarchaeological research will be evidence of pronounced mechanical loading as a result of strenuous activities that were performed over the course of many years. By way of a famous example of the effect of rigorous repetitive activity, we have what was coined atlateral elbow, caused by regular spear throwing, coined by Dr. Angel in 1966, one of the early scholars to demonstrate the usefulness of this field of inquiry. And in fact, this is quite like a modern condition known as tennis elbow. Extreme overuse of the extensor muscles on the back of the arm and around the elbow will cause bony arthritic changes. Also important in osteoarchaeological research about joint degeneration is a specific disease that occurs only in the spine called intervertebral disc disease or degenerative disc disease. The spine is unique. Unique because in between the bodies of the vertebra, there's a structure known as the intervertebral disc. The intervertebral disc consists of an outer fibrous ring, the annulus fibrosus, which surrounds an inner gel-like center, the nucleus pulposus, and it's crucial in shock absorption. The degeneration of this joint looks a bit different than that of synovial joints. With disc degeneration, the nucleus pulposus dehydrates, decreasing its ability to absorb shock, Recall from week 1 the loss of height that comes with age? Well, this is a major contributor to that. The annulus fibrosus becomes weaker and it has an increased risk of tearing. If there are fissures or tears, the inner nucleus pulposus can seep out. This can then put pressure on the vertebral nerves, and this is known as a herniated disc. Some of you probably know it can be quite painful. So what does this look like on the bones? Well, we commonly have these bony outgrowths along the margins of the vertebral body, osteophytes. And in the vertebra, these can get very large. Eventually, separate vertebrae may even fuse together, something known as ankylosis. We can also see abnormal pitting and porosity on the tops and bottoms of the vertebral bodies, as well as a change in the shape of the vertebra, so-called joint deformation. But there is another lesion that occurs only on the vertebra as an indentation in the bodies called Schmorl's nodes. These are more frequent in individuals with intervertebral disc disease, and thus sometimes related to activity. Schmorl's nodes are protrusions of the intervertebral disc into the body surface of the vertebra. So, as with osteoarthritis in synovial joints, intervertebral disc disease in the spine is caused by a range of factors, and the most important one is age. Simply speaking, the older you are, the more likely you are to have intervertebral disc disease, and the more likely it's affecting a larger percentage of your spine. But factors such as sex, diet, disease, and genetics are definitely important, as is the anatomical position of the vertebra, given how loading forces differ in different parts of the spinal column. One can easily envision that with high levels of mechanical loading as a result of strenuous and repetitive types of activity, distinctive patterns of intervertebral disc disease and osteoarthritis may emerge. For example, Dr. Nancy Lovell examined human skeletal remains from the Bronze Age period of the site of Harappa, a center of the Indus Valley civilization which prospered 4,000 to 5,000 years ago in what is modern-day Pakistan. She proposed that the high frequency of intervertebral disc disease and osteoarthritis observed in the upper or cervical spine might be related to the practice of carrying heavy loads on the head. For example, containers of water or clothing or firewood or food. So with that information, we're now going to turn to our case study. I'm very pleased to welcome Dr. Leida van der Merwe from the Academic Medical Center in Amsterdam. Leida, thank you for joining us today. Dr. van der Merwe conducted osteoarchaeological research on 19th century diamond miners from Kimberley, South Africa. So to begin, can you please tell us about what drew your attention to this very interesting skeletal collection and what were the main aims of the research?
In 2003, the Solplaatje municipality in Kimberley accidentally unearthed several unmarked graves next to what is currently known as the fenced Gladstone Cemetery. The McGregor Museum was alerted about these trenching activities. They halted the trenching and they received a permit to do the rescue excavation for the unmarked graves. The remains recovered needed to be investigated, so I was honored enough to do the investigation. The graves date to a really interesting time period in the history of Kimberley. They were dated to 1897, from 1897 to 1900. And that's a time period in which Kimberley was actually blooming and the diamond mining was really growing. The majority of labor on the mines was performed by migrant laborers working on the mine. And they were mainly, these individuals were admitted to Kimberley Hospital in case they got sick, and the hospital was actually using that part of the cemetery to bury unknown individuals. So the main aim of the study was to identify the individuals buried there, as some of the people in the surroundings thought that there were soldiers buried in that part of the cemetery, and to attempt to do a demographic profile, to assess the pathology, and then to see if we can figure out where they actually came from.
I see. So now let's focus on some of the paleopathological analyses, in particular when looking at the spine. So could you tell us a bit about what types of spinal pathology recorded, so spinal osteoarthritis and degenerative disc disease, and what were the results of those analyses?
After we did the demographic profiling of the population, we assessed the prevalence of degenerative disc disease and Schmoll's nodes in the collection. And in order to interpret the data, we reported that divided by sex and age group. Now, if you look at the Kimberley collection, they were mainly composed of young and middle adult males, and about 13.9% presented with degenerative disc disease and around 29% with Schmoll's nodes. So in order to say something about the data, we compared them to two other samples. The one was the vendor, and the vendor in this instance represents the rural lifestyle where the individuals came from. The vendor were of the same demographic profile, and the second sample was that from Koffiefontein, and that is also a mining migrant collection with the same demographic composition as the Kimberley skeletal remains. And if you compare those two, you see that they were actually more affected by degenerative disc disease and Schmoll's nodes than the vendor, and that the prevalences were comparable to that observed in Koffiefontein.
Very interesting. So then with that information in mind, and also with the historical data about the lifeways of these individuals during that time period, what were you able to conclude about their activity patterns?
We could conclude that they were indeed more affected by conditions such as physical activity that would actually cause an increased prevalence of degenerative disc disease and Schmoll's nodes. You could argue that this could also develop due to the very active lifestyle that they have in a rural setting, but they were actually significantly more affected than the vendor that actually represented this rural lifestyle. So we could definitely say with some certainty that that the mining had an influence on the prevalence of the degenerative changes that we observed.
Fantastic research. Thank you very much for joining us today. In this video, you've learned about joint degeneration, specifically osteoarthritis and intervertebral disc disease, and how osteoarchaeologists can use these as indicators of the activities of past peoples. We've seen how spinal degeneration research has improved our understanding of the activity patterns of diamond miners from the 19th century. Coming up next is the final case study of this module. We'll switch from focusing upon markers of activity in the skeleton to markers of activity in the teeth. See you soon.